Good morning students. Before watching this video, please make sure that you have watched part number 13 and 14 of this definite integrals. The topic areas under curves is going on. So actually 13 is the explanation of it, and 14th based on that areas under curves we have worked out some problems from exercise 7D. So let us continue. The fifth question is, find the area of the region bounded by the curves y is equals to sine 2x, y is equals to root 3 sine x equals to 0, x equals to pi by 6. So to work out this problem, there are two curves are there, sine 2x curve and root 3 sine x. It is obvious that these two curves are intersecting between 0 and pi by 6. So then whatever the area we are going to get in between 0 to pi by 6, we need to find out that area. But the thing is, these two curves are intersecting at 0 and pi by 6. Which is the above curve and which is the below curve? All these things have to be found out. So that is why, first of all, solving these curves, we get sine 2x is 2 sine x cos x. Since both are y, so we can equate them. This is equals to root 3 sine x. I've been telling you not to cut sine x and sine x on both the sides. If you do so, then one value will be missing. So for which 2 sine x cos x minus root 3 sine x is equals to 0. Sine x you take common, then 2 cos x minus root 3 equals to 0. Then either sine x equals to 0 or 2 cos x minus root 3 equals to 0. If sine x equals to 0, x equals to 0, or 2 cos x minus root 3 equals to 0, 2 cos x is equals to root 3, cos x equals to root 3 by 2. When cos x is root 3 by 2, x is equals to pi by 6. So did I say between x equals to how much? Cos x is equals to root 3 by 2. This is cos x is equals to root 3 by 2. It is pi by 6. Okay, between 0 and pi by 6. But here actually these two are already given. So in this interval, which is the above curve and which is the below curve, we don't know. So for which we need to take one value between 0 and pi by 6. Let us take x equals to 15 degrees. 0, this is 30 degrees, 15 degrees. So x is equals to 0, 30 degrees and 15 degrees, 30 degrees. Now, y is equals to sine 2x curve. Sine 2 into 0, sine 0 is 0. Sine 2 into 15, 2 into 15 is sine 30. Sine 30 is 1 by 2, which is 0.5. And sine 2 into 30, sine 60. Sine 60 is root 3 by 2. This is 1.732 by. This is this is 2. This is approximately 0.8. Likewise, y is equals to root 3 sine x curve now. Root 3 sine 0 is 0. Root 3 sine 15. Sine 15 value can be evaluated by sine 45 minus 30. Sine 45 cos 30 minus cos 45 sine 30. So if root 3 minus 1 by 2 root 2 we will be getting root 3 minus 1 by 2 root 2. So root 3 into sine 15 is root 3 minus 1 by 2 root 2. So this is root 3 minus 1 is, this is 1.732. This is 1.732 minus 1, 0.732 by 2 root 2, 2 into 1.414. If you do this calculation, 0.448 approximately we will be getting. And root 3 sine 30. Sine 30 value is 1 by 2. So root 3 by 2. So 0.8. So therefore we got to know that 0.5. Between 0 and 0.8, 0.5. Here 0 and 0.8, 0.448. Therefore, this is the dominating curve and this will be lying under this curve. Therefore, upper curve is sin 2x and lower curve is sin x. If you still don't know, then actually with the help of diagram, we will be trying to get it. So, let us plot the diagram. 0, this is 15 degrees. 15 degrees means pi by, this is pi by 6 by 2, so pi by 12. This is pi by 6. Now 0, 0 is this. This is 0.5 and above this will be 0.8. Okay, so 0, 0. Pi by 12, 0.5. Next, 30 degrees, 0.8 is this. So, this is the curve of sin 2x. So, if you want to know where this curve meets the x-axis, simply sin 2x equals to 0. Then sin 2x equals to 0, then sin 0, this is 0 degrees and x is equals to pi if you take, then again at pi this will give us 0. So for example somewhere like here, this is pi, which is not important, but still if you want to know the behavior of this, sin 180 is sin 90 plus 90 cos 90. Cos 90 is 0. So it cuts here. And here root 3 sin x. So 0, 0, 15, 0.48. 0.48 will be a little bit down. This. And 0.8 is this. That means this curve is this. So if you want to know where this curve meets the x-axis, sin 90 is 0. Okay, so this area is what we are required to find out. So therefore area is equals to between 0 to pi by 6. Between 0 to pi by 6, the upper curve is sin 2x. 0 to pi by 6 are the limits of x dx. Dx, y dx. Here there are two y's are there. Y equals to sin 2x, y equals to root 3 sin x. Just now we have seen that this is the upper curve. So y is equals to sin 2x minus y is here root 3 sin x. This is the below of sin 2x. So root 3 sin x. So we can evaluate from this onwards. Integral sin 2x is minus cos 2x by 2 minus root 3 integral sin x is minus cos x. Minus of minus is plus cos x. Since the process is over, 0 to pi by 6 is to be written here. Minus 1 by 2 cos 2 into pi by 6. Cos 2 into pi by 6 is cos pi by 3. Cos pi by 3 is 1 by 2. Minus cos 2 into 0. Cos 0 value is 1. Plus root 3 into cos 30 root 3 by 2. Cos pi by 6 is cos 30. Cos 30 is root 3 by 2 minus cos 0 value is 1. This is equals to minus 1 by 2. 1 by 2 minus 1 is minus 1 by 2. Plus root 3 into root 3 by 2. So root 3 into root 3 by 2 minus this is root 3. So minus into minus plus, this is 1 by 4. This is 3 by root 3 into root 3, 3 by 2 minus root 3. And answer is 1 plus 6 is 7 by 4 minus root 3. Sixth question, y is equals to x square, y is equals to x cube. Y is equals to x square, we know that it is of the form x square equals to 4ay, which is a standard form of the parabola whose vertex is at the origin, x power even symmetric about y axis. So there it would be upward parabola. So this we know. What about y equals to x cube? If we substitute x equals to minus x and y equals to minus y, then still minus y equals to minus x whole cube. Still same y is equals to x cube only we are getting. That means it is symmetric in the opposite quadrants. That is first and third quadrant. Actually, in our explanation of this areas under curves, the same curve I have taken example and actually have worked out the solution also there. So simply here it will be somewhat like this. The shape of this will be y equals to x cube is this. It is passing through the origin 0, 0 because x equals to 0 if you substitute y, so it will be satisfying 0, 0. That was only the rough sketch. So if you want to know the exact sketch of this, let us do this. That is y is equals to x square, y equals to x cube. One thing is sure that actually these two are intersecting curves. So the point of intersection will we get through the process of solving these two curves. So very first let us solve that. Solving the given curves. This is equals to both are, since both are y, therefore x cube equals to x square. X cube minus x square 0. X square if you take common, x minus 1 0. Therefore x equals to 0 or x equals to 1. Therefore these two curves are intersecting at 0 and 1. But for sure actually these two curves, which is the upper curve and which is the lower curve, is still to be found out. How? Through taking any value in between these 0 and 1. So I will take 0.5 which is in between these two and let us do that. So x equals to 0, 1 by 2, 1. Now y equals to x square curve. So 0 square 0, 1 by 2 whole square, 1 by 4 which is 0.25. Next 1 square is 1. Y is equals to x cube. 0 cube is 0. This is 1 by 2 whole cube which is 1 by 8. That is approximately 0.12 and 1 cube is 1. So actually one thing is sure that actually x square is the upper curve, x cube is the lower curve. So let us try to plot the diagram now. 0, this is 1 by 2, this is 1, this is 0.12 and this is 0.25, somewhere here. So 1 comma 1 is this. So if you plot this diagram, then this is the parabola. This is the parabola and this part is not required yet. Just to obtain the curve of a parabola, I just drag this also. Now 0, 0, 1 by 2 0.12 is this, and 1 1 is this. Now this is of so this area is what we are required to find out. So therefore area is equals to, here we can clearly see that 0 to 1, this is the parabola. Parabola is the dominating upper curve and this is the lower curve. So 0 to 1, upper curve is, so 0 to 1 are the limits of x. So dx means y dx. Here there are two y's, y equals to x square, y equals to x cube. Y is equals to x square is the upper curve, minus y equals to x cube is the lower curve. Integral x square dx is x cube by 3. Integral x cube dx is x power 4 by 4. Process is over. 0 to 1. So 1 by 3 x 1 cube minus 0 cube minus 1 by 4 1 power 4 minus 0 power 4. So 1 by 3 minus 1 by 4. 1 cube is 1. 1 minus 0 is 1 into 1 by 3. 1 power 4 is 1 minus 0. 1 into 1 by 4. So 4 minus 3 by 4 3s are 12. So answer is 1 by 12. The area of the region bounded by the two curves. One thing is clear that this is a parabola. So, but it is not in the standard form of the parabola. And this is the equation of a line. Which line? Straight line. Y equals to, this is of the form y equals to mx plus c. So the exact behaviors of this, where it intersects and all, so we cannot solve it directly since this is not a standard form of the parabola. Okay, with little efforts we can, but otherwise actually all we need to do is, first of all, limiting points are not given. Limits are not given. Therefore, we need to, these are the intersecting curves is what we understand. For which actually we need to solve them. First of all, the first prime duty of ours is to solve them. Solving the given curves, we get, since both are y, so equate both of them. 4x minus x square equals to 5 minus 2x. This is equals to x square minus x square if you transpose onto this side plus x square. So minus 2x minus 4x minus 6x plus 5 equals to 0. Now factorization we will do 5. So 5 ones are 5. 5 plus 1 6. So x square minus 1x minus 5x plus 5 equals to 0. So take x in common, x minus 1. Take minus 5 in common, x minus 1 0. So x minus 1 into x minus 5 equals to 0. Therefore x equals to 1 or 5. So one thing is clear that these two are intersecting curves between 1 and 5. So here between this 1 and 5, which is the upper curve and which is the lower curve, which we don't know. For which I will do one thing. On x-axis 1 unit I will take and try to plot the diagram. So x 1, 2, 3, 4, 5. So y equals to 4x minus x square. Now 4 ones are 4, 4 minus 1 is 3. 4 twos are 8, 2 square 4. So 8 minus 4, 4. Next 4 threes are 12 minus 3 square 9. 12 minus 3. 12 minus 9, 3. Next 4 fours are 16. 4 fours are 16, 0. 4 fives are 20 minus 25. So minus 5. This is over. And y is equals to 5 minus 2x curve now. So 5 minus 2 ones are 2. 5 minus 2 is 3. since both are giving the same values, that means both are intersecting at x equals to 1, that is to say. In the same way, needless to say, both are intersecting at 5, that means needless to say, this we are going to get minus 5. Otherwise, we may check it out also, doesn't matter. Now, so 2 if you substitute, 5 minus 2, 2s are 4, that is 1. 5 minus 2, 3s are 6, minus 1. 5 minus 6, minus 1. So 5 minus 2, 4s are 8, minus 3. So with the help of this, let us try to plot the diagram. Now this is 1, 2, 3, 4 and 5. Here this is 1, 2, 3, 4 and this is 5. 1, 2, 3, 4, 5. This is minus 1, minus 2, minus 3, minus 4, minus 5. Now 1 comma 3, 1 3 will be at this point. 2 4, 2 4 is this point. Next 3 3, 3 3 is this point. 4 0, 5 minus 5, 5 minus 5 is somewhere here. Okay, so you join this. So this is what we get. So we can understand that this is the parabola. Here if you substitute, so this is passing through the origin, which is not at all required. Okay, but still, just to obtain the shape of that curve, I have just show it in the diagram. Now 1 comma 3 is this. 2 1, 2 1 is somewhere here. Next 3 minus 1, 3 minus 1 is here. And 4 minus 3, 4 minus 3 is here. And did I tell you 5 minus 5? So both are intersecting at this curve. So this is a straight line. This is a straight line. That means both are intersecting at this point and this point. So this area of the region is what we need to get. So area A is equals to, from 1 to 5, from with respect to x-axis, 1 to 5 dx. Dx means y dx. But here there are two y's. What is this y? This is the parabola. Minus this is the lower curve line. P minus L dx. So that means 1 to 5 parabola is 4x minus x square minus this is 5 minus of 2x whole dx. This is equals to 1 to 5 4x minus of minus, so 6x minus x square minus 5 dx. This is equals to 6 integral x dx is x square by 2 3 times minus integral x square dx is x cube by 3 minus integral 5 dx, 5 integral 1 dx, so 5x. So since the process is over, so 1 to 5 is to be written here. This is equals to 3 into x square, so 5 square 125 minus 1 square 1 minus 1 by 3 x cube. Sorry, here x square is 25. X cube is 125 minus 1 minus 5 into x value is 5 minus lower limit 1. 5 minus 1, 4. This is 25 minus 1, 24. 24 3s 72. 72 minus 124 by 3 minus 5 4s are 20. So this is equals to 72 minus 20 is 52. So 52 3s 156 minus 124 by 3. So that is equals to 6 minus 4 is 2. 15 minus 12 is 32 by 3 square units. Find the area of the region bounded by the parabolas. Y square equals to 4x, x square equals to 4y. Both these parabolas are the standard form of the parabolas because their vertex is at the origin, point number 1. And y square equals to 4x is the parabola which is symmetric about positive x-axis. That means this kind of parabola. What is this? Y square equals to 4x. X square equals to its vertex is at origin 0 0. X square equals to 4y. Its vertex is also at the origin. X power even symmetric about y axis. Which y axis? Positive y axis, upward or downward? Y has got a sign positive, therefore it is an upward parabola. So this parabola. So clearly we can see that these two, this is the area of the region and these two curves are intersecting at origin and this point. That means this point of intersection we need to find out, for which let us solve them. Solving the given parabolas, we get this is y square equals to 4x and this is x square equals to 4y. So here from this y is equals to x square by 4. From this y is equals to x square by 4 we can write. So this is y square equals to 4x. This is y equals to. So y square equals to 4x. What is y? X square by 4 whole square is equals to 4x. Hope you get it. Again I am telling you, x square by 4, x square equals to 4y. Y is equals to x square by 4. This y is equals to x square by 4. I am substituting in this. What is y? X square by 4 whole square equals to 4x. You may ask a question, sir. Here x is equals to y square by 4. If we get and actually can we substitute back in this? Of course, in that way also we can do. We can do these problems in two alternatives with respect to x and with respect to y also. Okay, y dx or x dy even. So this is equals to x power 4. 4 square is 16 is equals to 4x. X power 4 equals to 4 16 64x. X power 4 minus 64x is equals to 0. Take x in common. X cube minus 64 is equals to 0. X equals to 0. So that is one point of intersection, origin. Is equals to, and x cube equals to 64. 64 can be written as 4 cube. So therefore x equals to 4. Therefore these two are intersecting at 4. On y axis, on x axis y coordinate is 0. So therefore area is equals to area A equals to from 0 to 4. So see this. This area is what we need to get, right? Taking x as the basis, so actually this is the upper curve and this is the lower curve. So what is this curve? This curve is y square equals to 4x and this curve is x square equals to 4y. So 0 to 4 are the x values. So here dx will take, if it is dx, y dx I will take. So 0 to 4, here this is y square equals to 4x. What I want is y. So y equals to square root of 4x. This is upper curve minus what is this curve? This curve is lower curve. So this is x square equals to 4y. From this y equals to x square by 4 whole dx. This is what we have to evaluate. So now see this. This is equals to root 4 is 2 integral root x dx 2 by 3 x power 3 by 2 minus 1 by 4 separated from the process of integration. Integral x square dx is x cube by 3. So now from 0 to 4. So 2 2s are 4, 4 by 3. In the place of x upper limit 4 power 3 by 2 minus in the place of x lower limit 0 power 3 by 2 minus 4 3s are 12. In the place of x upper limit 4 cube minus in the place of x lower limit 0 its cube 0 cube. This is equals to 4 by 3. 4 is 2 square whole power 3 by 2. 2 gets cancelled. 0 power 3 by 2 is 0 minus 4 cube is 64 by 12. Now this is 2 cube is 8. 8 4s are 32 by 3 minus 4 16s 4 3s. This is 16 by 3. So 3 LCM 32 minus 16 16 by 3 square unit. Find the area enclosed by the curves y is equals to x square plus 1, y is equals to 2x minus 2, x equals to minus 1, x equals to 2. So every curve's behavior we know. So y equals to x square plus 1. This is not a standard form of the parabola, but we can find out find the area enclosed by the curves y equals to x square plus 1, y equals to 2x minus 2, x equals to minus 1, x equals to 2. So every curve's behavior we can evaluate. See, y equals to x square plus 1. This is a parabola but not in a standard form. Its vertex is not at the origin, but we can find easily. Y is equals to, this is of the form mx plus c, which is a straight line. X equals to minus 1, x equals to k is the line which is parallel to y axis, it's a vertical line. X equals to 2 is also vertical line. So actually two vertical lines, one straight line, one parabola. So area of the region bounded by these we need to find. So for which solution, no need to take minus 1, 0, 1, 2 which we have done before. Otherwise we can do it directly also. See how. So here given parabola is y is equals to x square plus 1. This is of the form y minus 1 equals to x square. Therefore, this is of the form x minus 0 whole square is equals to y minus 1. So this is of the form x minus h whole square is equals to 4a into y minus k. So its vertex of this is a. Vertex is equals to h comma k. H value is 0 comma 1. Next, where it intersects the x-axis, so that also we know. Substituting y equals to 0 implies x square plus 1 is equals to 0, which is not required. Next, y is equals to 2x minus 2. If the given line is y is equals to 2x minus 2, substitute y equals to 0, then 2x minus 2 equals to 0, 2x equals to 2, x equals to 1. So this is 1 comma 0. Substitute x equals to 0 implies y equals to x equals to 0, so minus 2. This is 0 comma minus 2. So with the help of this available data, we can draw the diagram. See, this is the y is equals to x square plus 1, x power even, symmetric about y axis, and y has got a sign positive here. So it is upward parabola whose vertex is at 0 comma 1. So 0 comma 1 is somewhere here. This is 1. On y axis x coordinate is 0. So this is the parabola. This is the parabola. Next, y is equals to 2x minus 2. So this is 1 comma 0 is this. So this is 0, this is 1. So this is 1 comma 0 and 0 comma minus 2. So this is minus 1 and this is minus 2. So here 0 comma minus 2 is this. That means this is a straight line. This is a straight line. And x equals to minus 1. So this is minus 1. X equals to minus 1 is a straight line. X equals to minus 1 is this. And x equals to 2. So this is 2. 2 comma 0 we can take. So otherwise this is x equals to 2. Now listen. This if you extend, this is the parabola, and if you extend this is the parabola. So here we can see that both curves, which is parabola and a straight line, never intersect, but we want the area of the region bounded by minus 1 and 2. So this area is what we need to get. That means this area. So minus 1 to 2. So area is equals to minus 1 to 2. So the parabola is the upper curve. Below that line is there. So parabola minus line dx. So what is this? Y dx. Minus 1 to 2. Parabola. So y is equals to how much? X square plus 1. Minus of lower curve is 2x minus 2 whole dx. This is equals to minus 1 to 2. This is x square minus 2x minus into minus plus 2, 2 plus 1, 3 whole dx. Integral x square dx is x cube by 3 minus 2 integral x dx is x square by 2 plus integral 3 dx is 3 into integral 1 dx, 3x. So from minus 1 to 2. 2 gets cancelled. So x. So 1 by 3 into x cube. 2 cube is 8 minus x cube minus 1 cube minus 1. Minus of minus plus 1. Minus 2 square 4 minus minus 1 square 1 plus 3 into 2 minus of minus 2 plus 1 3. 8 plus 1 9 by 3 is 3 minus 4 minus 1 is 3 plus 3 3s are 9. So 9 square units. The area enclosed by the curve y square equals to 4x, y square equals to 4 into 4 minus x. Both these parabolas, whose vertex is at the origin and whose vertex is not at the origin. So, and since the limits are not given, that means these two are intersecting curves. So actually through solving, we will find the point of intersections. So solving the given curves, we get 4x equals to 4 into 4 minus x 4 gets cancelled. 2x equals to 4, therefore x is equals to 2. So the vertex of y square equals to 4x is y minus 0 whole square equals to 4 into x minus 0. Therefore vertex is 0 comma 4. Sorry, 0 comma 0, whose vertex is at the origin. And for the parabola y square equals to 4 into 4 minus x implies y square equals to minus 4 into x minus 4. This implies y minus 0 whole square equals to minus 4 into x minus 4. So this vertex is 0 0 and symmetric about positive x-axis. Here vertex is equals to 4 comma 0 and symmetric about here y power even symmetric about x-axis, negative x-axis. So if we try plotting the diagrams, so it will be something like this. 4 comma 0 is 1 2 3 4 is 4 comma 0 2 3 0 0 and 4 comma 0, the vertex of this is 4 comma 0 and it is symmetric about the negative x-axis. It will be opened in negative x-axis. So this is that curve, that parabola. Next, because x-axis is acting like a mirror. See, if this and this are same, this x-axis cuts the entire portion into two equal parts. And here vertex is 0 0, symmetric about positive x-axis. So, and both are intersecting at which point? X equals to 2. So x equals to 2 means this. So both are intersecting at 2. So both are intersecting at 2. So from 0 to 2, this parabola is there, y square equals to 4x, and 2 to 4, this parabola is there, y square is equals to 4 into 4 minus x. So if we get that, actually we will be getting the upper portion. If we want to get the lower portion also, since it is symmetric about x-axis, whatever the answer that we are going to get into 2, if you multiply, we will be getting the whole area. So let us do that. So this is y square is equals to 4x, and this is y square equals to 4 into 4 minus x. Area is equals to 0 to 2 dx. Dx means y dx. So y dx. So this curve is y square equals to 4x. Y is equals to square root of 4x. So 2 root x dx plus from 2 to 4, this parabola is y square is equals to 4 into 4 minus x. So 2 to 4, square root of 4 into 4 minus x. So 2 root of 4 minus x. Because if we want y square is this, y is equals to square root of 4 into 4 minus x. Root 4 is 2 root 4 minus x dx. This is equals to 2 integral root x is 2 by 3 x power 3 by 2 from 0 to 2 plus 2. 4 minus x integral root 4 minus x is 2 by 3 4 minus x whole power 3 by 2 by quotient d by dx of 4 minus x is minus 1 from 2 to 4. So 2 2s are 4 by 3 is a constant. X is 2 power 3 by 2 minus x value is 0 power 3 by 2 is 0. 2 2s are 4 by 3 minus. So minus 4 by 3. 4 minus x value is 4 whole power 3 by 2 minus 4 minus x value is 2 whole power 3 by 2. This is equals to 4 by 3. 2 power 3 by 2 is 2 root 2 minus 4 by 3. This value is 0 minus 4 minus 2 is 2 power 3 by 2, so 2 root 2. This is equals to minus into minus, so 4 by 3 into 2 root 2, 4 by 3 into 2 root 2. This is 2 into 4 by 3 into 2 root 2. Because 4 by 3 2 root 2, 4 by 3 2 root 2. 2 into 4 by 3 2 root 2 we have. So 2 4s are 8, 8 2s are 16. 16 root 2 by 3. So this is only this area. If you want to know this area, so the result we have to multiply with the 2. Therefore, total area is equals to 2 into 16 root 2 by 3. 2 16s, 32 root 2 by 3 square units. Find the area enclosed by the curve y equals to 2 minus x square, y equals to x square. Same, these are the two curves, two parabolas. It is a regular parabola, standard parabola whose vertex is at the origin, but here vertex we need to find out. And since the limits are not given, therefore these two are intersecting curves, and between those 2 points of intersection we need to find out the area. So solving the given curves, we get 2 minus x square equals to x square. 2 is equals to 2x square. Therefore, x is equals to plus or minus 1. The vertex of y is equals to x square is 0 0, which is symmetric about x power even symmetric about positive y axis. Next, here for the parabola y is equals to 2 minus x square implies x square is equals to 2 minus y. Further, x minus 0 whole square is equals to minus of y minus 2. So its vertex is this could be compared with x minus h whole square equals to minus 4a into y minus k. So 0 minus 2 and which is symmetric about x power even symmetric about y axis, negative y axis. That means let us try to plot the diagrams. So first the vertex of this is 0, 2. 0 comma 2 is on y axis. This is 0 comma 2. So this is 0 comma 2 and it is symmetric about y axis, negative y axis. It is opened in the negative downward y axis, and here this is positive y axis 0 0 and symmetric about positive y axis. So both are intersecting at -1 plus 1. So this is -1 and this is plus 1. This is -1. So therefore this is the area of the region bounded by these two curves we want. So area is equals to, from -1 to 1, this is the upper curve. Which is the upper curve? Y is equals to 2 minus x square. So this is y is equals to 2 minus x square. This part is y is equals to 2 minus x square. So y dx means 2 minus x square. This is upper curve minus lower curve is this. This is y is equals to x square is x square dx. Integral 2 dx is 2x minus x square minus 2x square. So 2 into integral x square is x cube by 3. So from -1 to 1. 2 into upper limit 1 minus lower limit -1. Minus of -1 plus 1 2. Minus 2 by 3 into upper limit 1 cube 1 minus -1 cube is plus 1. So 2 2s are 4. 1 plus 1 is 2. 2 2s are 4. 4 by 3. 3 4s are 12 minus 4. 8 by 3 square units.